Once again, our lesson for today is linear equations and functions. So we're extending now what we saw last time in regard to relations and functions. And now we're getting into graphing, and today specifically linear equations. Linear functions, Just to remind everyone, we're still attending to precision with math practice standard number 6. So those of you that need to give me like full sentence answers, or make sure you address the question, make sure you think about the question that they're asking and answer correctly what they're asking for. And we're still looking for and making use of structure, so make sure you pay attention to that. Our objective for today, I can write and graph linear functions. Let's read it together. 1, 2, 3. I can write and graph linear functions. So linear functions, like I said, we already covered functions, but today we're going to focus on linear functions. So let's see. Linear functions. You have the definition there in your Cornell notes. It says, a relation that assigns exactly one output value for each input value in two variables and has a constant rate called a change. I want you to underline the word relation, a relation. We already know what a relation is, okay? And we're going to cover that right now again as to what we did for our introduction, okay? The other thing that I want you to underline is two variables. Okay? So, if I was to give you this example, and you already have it written down, right? And I said, when we first started with relations and functions, I said a relation is a collection of ordered pairs. Do we have a collection of ordered pairs here? Yes. All these are ordered pairs. They're collected in the set. That's a relation. What makes it a function is that first thing we do, we scan through it and to see if we have any x values that repeat. Do we have any x values that repeat? Yes. Which one is that? The -2. Do you guys see that? -2 repeats here, and the other -2 is right here. To make sure it's a function, the y value has to be the same. What is the y value here? 3. What is the y value over here? 3. So therefore, this is a function. Okay? And we're going to be writing these in equation form. And this is what it looks like. The first linear function in equation form looks like this. Write this down. Y equals 2x plus 1. Another one would be y equals -3x plus 4. And another one would be y equals 2/3 x minus 23. Write those down, please. All right, check this out. According to our definition, pay attention, please. So, let's see. According to the definition, it's a linear function is a relation. Here it is, with exactly one output for every input, and we saw that the -2 repeated, and we got 3 as an output, and that's why this is a function. And this is what linear functions look like in equation form. Does it have two variables? Yes, y and x, and these have also a constant, okay? Let me show you what a non-example is. So check this out. If they give us this relation right here, this is a relation, okay? Because it's a collection of ordered pairs. But this is not a function. So think about it. If this is a function, why is this not a function? Think about it first. Talk it over with your neighbor, please. That the y value of the beginning of the relation here is not the same as this one because the -2 repeated, right? That's why it's not a function. The -2 repeated, and the y value is not the same for the same one that repeated. Okay? All right? So with that said, let me show you the graph. I gave you guys a graph that looks like this, right? And I remember when we did introduce functions, I said you can do a line test. So you can get your pencil. Imagine this is my pencil, and I'm going to scan it from left to right. And when I scan it from left to right, as soon as it touches 2 points on that graph, it's no longer a function. And notice here, it's touching that. This is a graph, this figure here, and it's touching a point here, and it's touching a point there. Therefore, it's not a function. Yes? When the points are aligned vertically like that, and your vertical line test touches that 2 points, it's not a function. Okay, yes? If it's a squiggly line, like I said, if it's a squiggly line, but if you scan it and it only touches that 1 point all the way through, it is a function. But if the squiggly line overlaps in a couple of places where your line test touches, then it's not. So check this out. You can do this one. Everybody look up. Let's say I do this squiggly line. That's a function. Let's see. Let's double check. 1 point, 1 point. You see how it's only touching that 1 point there? 1 point there, 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 there. It only touches that 1 point, right? Watch. You can't test it horizontal. That's why it's called the vertical line test. It's a vertical line, right? Isn't this a vertical line? Yeah, that's why this is called a vertical line test. So now check this out. But what if I did this? Watch. What if I did this squiggly line, like that? And I scan this through it. Let's see. Oops, it's touching here and here. Therefore, it's not a function. Okay? So with that said, also let me show you what in equation form, what is not a function. Check this out. Copy this one down. Y equals x squared plus 4 and y equals x cubed plus 1. Copy those, please. Look at what linear functions look like and look what is not a linear function. Talk it over with your neighbor. Why are these linear functions? Why are these not linear functions? So yeah, so the one thing that we saw is that these don't have exponents, or they have an exponent of 1 on the variable x, and these have other exponents. So let me show you what these look like if I was to graph these linear functions. Check this out. This one looks like that. This one looks like that. And this one looks like, oh, sorry. This one looks like that. And you're saying, why did you, Mr. Q, why did you do it again if you already have like, but look at the direction. This one's going up faster from left to right, right? This one's going up slower. I just want to show you a couple things. We're not going to get into those yet, but I just wanted to show you a couple things. But let me show you what this looks like, why it's not a linear function. This one looks like this. And you did these in 7th grade. Let me show you this one. This one looks like that. What do you notice? These are linear functions because they make a straight line. This is not a straight line. This is a curve. This one starts off as a line, but then it curves and it becomes a line again. Yes, but is it a linear function? No, it's not a straight line. So these are straight lines. These are not. Copy that, please. All right, so the most important thing to remember about linear functions is, number one, what did I ask you to underline over here? It's a relation, so write it right here so you remember. It's a relation. It's a relation. What else? They have one output for every input. And what else? It has a constant rate of change, which is called the slope. We'll get into slope later because I am going to do a formal introduction to it. I just wanted to touch bases in regards to the other pieces. Okay? Bless you. Okay? So from there, I gave you guys some steps. There's 5 basic steps that I want you to follow in regards to graphing functions, linear functions. Okay? All right, let's move on. Okay, check this out. So the steps: solve for y, write an input-output table, plot your points, graph your function, and check another point to see if it's on the line. So you already have them written there. I'm going to go ahead and get started with the first example, okay? So what I want you to do, I want you to switch from the Cornell Notes to the graphing paper. I want you to get the big graphing paper in front of you, okay? The big graphing paper, or the big coordinate plane, okay? It has two sides, one with small and one with a big one, okay? All right, here we go. So copy this example at the top left. Example 1A, top left. Example 1A. You're going to write graph y equals 2x plus 1. Tell whether it represents a function. Graph y equals 2x plus 1. Tell whether it represents a function. Copy that. And I'm going to go ahead and do this one step by step so you guys can see that how the 5 steps that you have there apply to all the processes that we're going to do. Okay? So check this out. So first steps first. According to our notes, the first step to graph linear functions is to solve for y. Look at this equation. Is y by itself already? Yes, that means it's already solved for y. So step 1 is done. Step 2, what does step 2 say? Look at it. Step 2 says, write an input-output table. So that means on the left side, I want you to do that together with me. On the left side of the graph, you have a blank space, right? Going down, you have a blank space. I want you to copy this table. X, Y, draw a line down, one across. And we're going to write a domain. Okay? A domain. Now, let's see if you remember from what we covered from domain from the last lesson on relations. We said domain are all x values. So in this case, we don't have any. I'm going to give you the domain. The domain that I want you to write is from -2 all the way to 2. So you're going to write -2, -1, 0, 1, 2. Copy that, please. So the domain is from -2 all the way to +2. So you're going to write -2, -1, 0, 1, 2. From this point forward, when we're graphing and I don't specify what values for x, I want you to use the domain from -2 to 2. From this point forward, when we graph, and I don't give you specific numbers for the variable x, I want to use the domain -2 to 2. So what domain are we going to use? -2 to 2. Are we there? All right. So we're still building writing our input-output table. We're not done. This is how we write the y values. I'm going to write the equation first. Y equals 2, and instead of x, I'm going to open a parentheses plus 1. Okay? You're just paying attention. I'm going to do this first. Okay? Once I ask you to copy that, you're going to copy this under your table where you wrote your table. So like that, you can continue writing down there. Okay? Here we go. So in order for me to get my y values, which are these, my range, I need to substitute this in here. So what is my first value? -2. So y equals, what is 2 times -2? -4 plus 1. What is -4 plus 1? -3. That goes right there. Are we there so far? Hold on. Let me do another one so you can see it. I write this again. Y equals 2, open parentheses, plus 1. What would be my next value? -1. So therefore, y equals 2 times -1. That's -2 plus 1. Y equals 2 times, 2 plus plus 1 is -1. That goes here. I'm going to do one more. Y equals 2, open parentheses, plus 1. This is 0. Y equals 0 plus 1. So y equals 1. Copy that, please. And then I'll show you how to get the other two. Go. Here. Now check this out. We can continue doing that to get the other values. Okay? So we have our domain here. We're filling our range. But now we can actually use patterns. So check this out. It's kind of like the movie The Matrix. Who's seen The Matrix? Or who of your parents has seen The Matrix? I know you guys can't see it, right? So, anyways, The Matrix is this futuristic movie where this guy can see like stuff and it's just numbers and stuff. It's pretty cool. Anyways, check this out. I'm gonna see if you see what I see. Here it goes. Get it? I'm gonna see if you see what I. Anyways, all right, here we go. Everybody look up. Pens down, eyes up here. Focus. Now, this is what I do. I usually try and look for patterns to save me a lot of work, just in case I need to do more points here. I start trying to see if there's a pattern from here to here, and if you see it, don't say it out loud. Something's happening from here to here, from here to here. Okay? All right? Some of you already saw it. If you saw it, I want you to fill in those two spaces, please. If you didn't see it, I want you to do the work the long way, please. Yeah, if you don't see it, do the work. If you do see it, fill the space. Go. All right, so according to my pattern, this should be a 3, and this should be a 5. Hands if you got that. Okay? Right, so therefore, check this out. So with that said, step 1 says solve for y. Did we do that? No, because it was already solved for y. Step 2, write an input output table. Did we do that? Yes. Step 3, plot your points. So I'm going to plot my points. I'm going to start with this one. My first point is negative 2, 3. Pens down, eyes up here. I'm going to show you the process so that you don't. Okay, here it goes. Negative 2 of x, 3 of y. I start at the point of origin, which is the center. So, I'm going to graph this first one. I start at the point of origin, and it says x is negative 2. So, therefore, I go 2 to the left. But y is negative 3. Y is negative 3. That means I go down 3 steps. 1, 2, 3, and I plot my points. Now, some of you get confused with graphing, and I'm going to show you an easy way of saying this. Check this out. This is a corner. Everybody look up, please. This is a corner of Donut Avenue. And you tell someone, I'm going to meet you at Donut Avenue so we can buy a torta and a nice tea, half and half, no lemon, easy ice, right? So check this out. So you tell them, well, I'm new here in town. I don't know the direction. Give me the address or the streets. So you say, this is Main Street, and this is Bariani, right? So therefore, is the person going to stand just on Main Street? No. Are they going to stand on Bariani? No, they're going to stand at the corner of Main and Bariani. That's how you plot your point, at the corner of negative 2 and negative 3. Copy that, and let's do the rest together. So here we go. Next one. Negative 1, negative 1. We start from the center again. Negative 1 of x is to the left. Negative 1 of y is down. And at that corner, they meet. There it is. Next one. 0 of x, 1 of y. I start at the center. Where's 0 of x? Right there at the center. 1 of y is up here, and I plot my points. Next one. 1, 3. 1 of x, I start from the center. 1 of x is to the right. 3 of y is up 3 steps. 1, 2, 3. And I plot my points. And the last one, 2 of x, 5 of y. I start from the center. That's 2 of x, 5 of y. 1, 2, 3, 4, 5. So, step 1, solve for y. Step 2, write an input output table. Step 3, plot your points. Did we plot our points? Yeah, step 4, graph your function. Grab your ruler, connect the dots, the points. Make sure you extend your line as far as you can, please, and then draw arrows at the end. Extend it all the way as much as you can. Extend it. Here, let me show you what extended means. Let's see. Here it goes. There it is. All the way through. Go. All right. So step 1, solve for y. Step 2, write an input-output table. Step 3, plot your points. Step 4, graph your function. Step 5, it says, Priscilla, what did it say? Check another point to see if it's on the line. So if I was to write in here, in my table, another point, I'm going to extend this like this. And if I was to write another value for x, what value would I write here? 3. And according to what I've been doing, or my pattern, the next number up is what? 7. So do the same, please. Put that on your table. And since you extended your line, I want you to plot the point, and it needs to fall and hit that line. If it didn't, then your line was crooked or you made a mistake. Okay? All right. So according to our point, check this out. I plot this point, 3, 7, let's see. I start at the center, 3 of x, 7 of y, 1, 2, 3, 4, 5, 6, 7. Did it land right on that line? Yes. Okay. So now, we got the testing point, okay? Now they're asking us, tell whether it represents a function. So we're going to do the vertical line test. With your pencil, going up and down, vertical, right? Vertical, up and down, vertical, up and down, vertical. Okay, you're going to put your pencil like this. I'm going to scan it from left to right and see if it only touches at one point. Let's see. Yep, 1 point. Yep, 1 point. Yep, 1 point. Yep, every step of the way is a point. Yep, 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 yep. So if I go all the way through, it only touches 1 point all the way through. Therefore, this one you're going to say, yes, function. Okay? Yes, function. Okay? Any questions with this? Pretty good? All right. So, 5 easy steps. Let's see if you can do the same. So let's go to the next example. Turn your paper over to the small graph on the left. Here we go. Copy this down, please. Example 1B. Example 1B. For this one, you don't have to copy the words since you already have the instructions in the front. Just copy the equation. The equation given for example 1B is 15x plus 3y equals 9. And you're copying it at the top left of your graph, right? All right? So now, let's go through our steps. Step 1 says, solve for y. Is it already solved for y? No. Therefore, you draw your line down your equal sign, and when you start leaving the y by itself, what do we do here? We first get rid of the x. How do we get rid of the x? Let's see. This is a positive 15x, so we subtract 15x. Subtract 15x. This cancels. We bring down the 3y, the equals. From now on, I want you to write the variable first. So this is negative 15x. And at the end, the constant. What is my constant? Positive 9. Are we there so far? Is y by itself already? No. What's next to it? The 3, and it's multiplying. Therefore, we need to divide by 3. Divide by 3. Y equals, what is negative 15x divided by 3? Negative 2x plus, oh, okay, my bad. I did that on purpose here, paying attention. Okay. So therefore, what is it? Negative 5. 15 divided by 3 is negative 5. What is 9 divided by 3? 3. So now, do we have an equation that we can graph? Yes. So step 1, did we solve for y? Yes. What is step 2? So go ahead and build your input-output table. Tell your neighbor what domain you're going to use. Okay? So therefore, let me get my graph ready. And my equation was y equals negative 5x plus 3. Here's my table. X, y, negative 2, negative 1, 0, 1, 2. All right? That's an ugly 2. Let me fix that. Two. So I'm going to write my equation again. Y equals -5, but instead of x, I open a parentheses, plus 3. What is my first value? -2. So what is -5 times -2? Positive 10 plus 3, that is 13. We do it again for the next number. Y equals -5, open parentheses, plus 3. So my next value for x is what? -1. What is -5 times -1? Positive 5 plus 3, that is 8. We do it again for the next one. Y equals -5 times parentheses plus 3. And my next value to substitute in there is 0. So therefore, -5 times 0 is 0 plus 3. What is 0 plus 3? 3. So now, at that point, everybody look up. You should be able to find a pattern. Don't say it out loud. Keep it to yourself. And if you find the pattern, fill in the other two. If you don't, continue what you're doing with the work to fill in your table. Go. All right, so let's see. What value did you get here, Ash? -2. And how about right here, Iram? -7. No, because you said it with a question mark. Is the name? Okay, thank you. So yes. All right, so let's plot our points. Here we go. This one, -2, 13. -2, 13 is somewhere up here. Yes? Next one, -1, 8. -1, 8 is right there. 0, 3 is right there. Next one, 1, -2 is right there. And the next one, 2, -7 is down. Let's see. 2, 1, 2, 3, 4, 5, 6, 7 is right there. And if I graph my line and I extend it as much as I can, it should look something like that. Yes? Okay, does yours look something like that? As nice as mine? I don't know, because I ask it to be nice. All right, so let's see. So step 1, did we solve for y? Yes. Step 2, did we write an input-output table? Yes. Did we plot our points? Yes. Graph our function? Yes. Step number 5, tell whether a point is on the line. So what point did you discuss? What was the point? And -12. So let's see if that's on the line. 3, -12. Yep, it is on the line. Okay. All right. And the question, tell whether it represents a function. Is it a function? Yes. Function. Okay. All right. So let's go to the next small coordinate plane. Let's go to the next one. Example 1C. Copy this down, please. Example 1C. Copy this equation. X equals -2. X equals -2. X equals -2. Copy that, please. So, pens down, please. Let me show you how this one looks. Notice, the first thing you notice is it doesn't have a Y. Is that correct? All right. So check this out. So for these, if I was to build an input-output table, what is the X value? -2, -2, -2, -2, -2. And you're saying, isn't it from -2 to 2? Yeah, but is there a Y value? No. And what is the only value that they give us? -2 of what? X. That's why for anything that we do for Y, it's always going to be what? -2. So does it matter what number I substitute for Y? No. What is the only value for X? -2. So let's say I said 1 of Y. What is X? If I said 0 of y? How about negative 2 of y? How about 5 of y? So it doesn't matter, right? So this is what it's going to look like. Everybody look up. I plot my point at negative 2, and I draw a vertical line going through that point, and I'm done. Okay? It is. So now, they're asking, tell whether it represents a function. So let's do our vertical line test. I get my pencil. Here it is. And I'm going to scan it from left to right and see if it touches at more than one point. Let's see. The whole thing. It touches all the points. Therefore, this is not a function. So far, so good? Okay? Next, copy this next one down on the next graph. Y equals 8. Y equals 8. No, just copy it. Okay? So check this out. So for this one, if I was to build an input-output table, X, Y, what would be the value that repeats on the Y? Does everybody see that? Because that's the only value that you are able to get for Y. Because Y is what? 8, 8, 8, 8, 8. So what does that tell you here? That we can actually fill the domain. This is negative 2, negative 1, 0, 1, 2. So therefore, if I plot my point at Y equals 8, where's Y equals 8? It's right here. And this is how you graph it. There it is. Horizontal. Yeah, this one's horizontal. Okay? Vertical. Right. So check this out. What? No, you can't because there's no X. I know. Well, we put it for the graph, but there's no X on the equation. So let's check to see if it's a function. I'm going to scan it from left to right. Let's see. Does it touch at one spot? Yeah, 1, 1, 1, 1 point all the way. It is a function. Yes. Function. Okay? Okay, so copy this on your Cornell notes. So we're done with graphing. Copy this on your Cornell notes. In the back side of your Cornell notes where you have a blank, copy this down. Forms of linear equations. Draw an arrow. This is Y form, standard form, and point slope form. Y form. There's two types that we've seen so far. Okay? We've seen something that looks like this. Y equals negative 5 plus 3x. And I asked you to write it in a different way. Y equals 3x minus 5, right? With the variable first. This one has a specific name, and I'll introduce that later. I don't want to get you confused. But these are the two different Y forms. But today, I want you to focus on this form, standard form. Standard form looks like this. AX plus BY equals C. AX plus BY equals C. That's standard form. AX plus BY equals C. What do we notice about standard form? So check this out. The first thing you should notice, hold on, give me a second. Let me get this out of the way. The first thing that you should notice, if I draw my line down the equal sign, is that both variables X and Y are on the same side of the equation. Do you see that? Okay? So therefore, if they give you an equation and they want you to write it in this form, and you're saying, but it doesn't look the same with variables and numbers. No, but what do we know in specific? That both variables X and Y are on one side of the equation. Are we there so far? Okay, copy this down. Example number 1. Don't pay attention to point slope. If you already wrote it down, that's fine. We'll get to that later. I'm just showing you some of the forms that you're going to look at. Copy this down. Example 3A. I want you to write X equals 2Y plus 4. X equals 2Y plus 4. Write this equation down. Yeah, where we were. And then they're asking us to write this in what? Standard form. Standard form. And then they want, give the values of A, B, and C. So check this out. If they want it in standard form, it should look like this. AX plus BY equals C. So, everybody look up, pens down, eyes up here. What do you notice? That the X is on one side, the Y is on the other. So what do we need to bring on this side? The Y. So how do we cancel the 2Y from here? Subtract 2Y, subtract 2Y. What do I write first, the X or the Y? X, and then minus 2Y equals 4. So now, does it look like this?
No.
Yes. X is first, and then Y. So they want us to identify A, B, and C. So check this out. What is the coefficient of X? 1. What is the coefficient of Y? Negative 2. And what is this? The constant is 4. So therefore, what is A? 1. Okay, my bad. What is B? Negative 2. And what is C? 4. Copy that, please. Okay, and pretty much that's the homework. Only one more different example, and I'll show you that right now. Everybody copy that? All right, check this out. So that's how we find, number 1, this is how we write in standard form. Do you guys see that? And number 2, they want us to identify A, B, C because you wrote your form, and now you know that the coefficients and the constants are A, B, and C. Are we there? Now let me show you the last example. Okay, don't copy this, just pay attention. Copy this equation down. 2x plus 5y equals 16. Yeah, now copy. Example 4a. 4a. Example 4a. 2x plus 5y equals 16. 2x plus 5y equals 16. And they're saying, without graphing, I want you to tell whether this point is on this line if we were to graph this, right? So we know the process to graph this. Solve for y, write an input-output table, plot your points, graph your function, and check a point, right? And this will be the point to check. However, let me show you how to do it without graphing. Pens down, please. I rewrite this, but instead of the variables, I substitute the value that they give us. What is x here? 3. So 2 times 3 plus 5 times what? 2 equals 16. What is 2 times 3? 6. That's 10 equals 16. Is 6 plus 10, that's 16. Is 16 equal to 16? Yes. When this is true, then you say yes on the line. So what happens if this is false? No, it's not on the line. Simple as that. Everybody got it? Okay, homework is on pages what? 260, 261, numbers 1 through 31, odds. Have a good one, guys. Enjoy your homework. See you guys to tutoring or tomorrow. Yo.